Hey everyone, welcome back to Algebra 2 Easy. We are going to be talking about multiplicity. Multiplicity describes how many times a zero or a factor occurs for a function. So, for instance, if you look at our first graph here, notice how this line is just going straight through the x-axis. Well, that would be a multiplicity of 1. That's why you see p equals 1 here. That just means that there is one single zero, x equals. So for instance, I'd have 1, 0, whatever x value that is. Now that middle graph is a representation of a multiplicity of 2. You see how it bounces off of the x-axis? So it was traveling down and then it bounced and went back up. Anytime a graph bounces on the x-axis, that is a multiplicity of 2. So that's going to be x equals and x equals, meaning we're going to have 2 of that same x-intercept. With a multiplicity of 3, that means that 0 technically is occurring 3 times. So multiplicity tells me how many zeros occur at that location. So let's practice. Here's a function, and I'm going to take my highlighter and just highlight where I see the function crossing or touching the x-axis. And I see that right here at -3, -1, and 2. What I will do next is write those x values. Crosses the x-axis at -3, crosses the x-axis at -1, and crosses the x-axis at 2. I'm going to work backwards now and write the factors. That would mean this factor is x plus 3. This one becomes x plus 1, and this one is x minus 2. Now, to describe the multiplicity, you'll raise each factor to the power of that multiplicity. So for instance, looking here at where the graph is crossing at -3, notice how it's passing straight through. It's not flattened and it's not bouncing back. So x plus 3 has a multiplicity of 1. So I'm going to add the exponent of 1 here. Now let's look at -1. See how it's flattened out? It's still passing through the x-axis, which means it's an odd multiplicity, an odd number. We know it's not 1 because it's flattened at -1. We would say it has a multiplicity of 3. If it was a higher multiplicity, like 5 or 7, also an odd number, it would need to be a more exaggerated flat line. So x plus 1 has a multiplicity of 3. Now let's take a look at the last intercept, and that was here at 2. Notice how it just touches the x-axis and bounces back up. That means it's going to have an even multiplicity. The higher the multiplicity, the flatter that bounce will look. This is not a flat line, it just bounces right back. So we would say this has a multiplicity of 2. Now we've identified the x-intercepts. Use those to find the factors, and then analyze the graph to determine the multiplicities. I hope this helps, and be sure to follow us for more.